Okay, hello and welcome to another section in further mathematics. We'll be looking at the ratio of general angles, but before that, let us take a look at our previous lesson. Okay, welcome back. You know, actually in our previous lesson we said something in regards to trigonometric functions, and we actually made mention of a sine of angles, let's say theta, the cosine of angle, let's also make use of the word theta, and the tangent of angles, which we also made use of the word theta in classifying some of the factors. Now, when we're talking about angles, I stated clearly that most times we apply this mostly when we have the right angle triangles. Okay, today I want us to go into ratio of general angles. When you talk about ratio, we want to talk about quadrants of angles and their respective values. Let's say, for instance, this is a circle. The total angle that makes up a circle is 360 degrees. Now, having 360 degrees, let's assume we decide dividing the circle into 4 equal parts. You bear with me that one of these parts is going to be, we'll be having 360 divided by 4, which is equals 90 degrees. So this first part is called 90 degrees. This other part is 90 degrees. This other part is 90 degrees, and the last part we also call it 90 degrees. So by the time you add 1, 2, 3, 4, you're getting a sum total of 360 degrees that makes up a circle. Now there's something I want us to understand. You know, naturally when we did trigonometry, I told us something that when you talk about, we're talking about angles and circle, we have quadrant. Quadrant is being used in this context because we're talking about dividing the circle into 4 equal parts. That's why we make use of the word quadrant from the word. So we have to divide this into 4 parts, 1, 2, 3, 4. And when we are considering angles and sides in a quadrant, we don't move in the clockwise direction. We always assume the anti-clockwise direction. So we're starting from here. This happens to be the first quadrant. We're taking this point to be in the second quadrant. This is the third quadrant, and this is the fourth quadrant. And in the first quadrant, I want us to deal with it separately. Now, when you're talking about the first quadrant, we are to create this and divide it into 4. You know, when we're dealing on graphs and everything, we discover that this part is called the positive y-axis. This part is called the positive x-axis. This point is called the negative x-axis, and this part is called the negative y-axis. These are the 4 axes that makes up cardinality when it comes to division of segment. Then, well, let's produce an angle here. I want us to take a judge at this and project it down, and let's call the angle theta. You know, this point is also 90 degrees. So this is our plus x, which is x. Up here is y, so this is y, which is plus y. Then let's take the resultant being p, which happens to be the resultant. I want us to go into proving something. Okay, I said something in our last class that we consider so ka sua each time we are dealing with sine, cosine, and the tangents of angles. So if we want to take the value of sine theta, these are theta. So let's move with socatua. So as I remember in our last class, we said this stands for sine, this is cos, and this is tan. So let's apply it. Sine theta, the O here stands for opposite. This is our theta, and this is the angle opposite theta, which happens to be what? Y. So the O here is y over hypotenuse here is p. So we have the value p. And in the same vein, we also have cos theta is equal to adjacent. So this is theta, this is opposite, this is hypotenuse. That is the longest side of the right angle that we are considering. So this other side is called the adjacent. So the adjacent here is x over, then x over hypotenuse. The hypotenuse is p. So we still have it this way. Okay, the hypotenuse is p. Then let's talk about tan theta. If you take tan theta in consideration, tan stays opposite over adjacent. So where is the opposite? The opposite part of it is still y all over. The adjacent is what? S. You could discover that after all evaluations, that the value of sine theta, cos theta, and tan theta assumed a positive value. You didn't have anything like minus x or minus y in any of the analysis. That is to tell you that, we divided it into 4 different parts. We said the first quadrant, the maximum angle there is 90 degrees. Then in the second quadrant, you have 180 degrees as being the highest obtainable angle. In the third quadrant, 270, and in the final quadrant, 360. That makes up the summation of the total angle found in a circle. So with this analysis, we'll definitely see that sine of angles, cosine of angles, and tangent of angles of numbers that fall within the first quadrant always assumes a positive value. That is to say, if you have from sine 1 degree to sine 90 degree, assumes a positive value. So let's say, for example, if you have sine 50. Now you bear with me that 50 is within the range of 1 to 90, so it's a member of the first quadrant. So sine 50, like if you have it, you see is sine 50. Remember how to analyze it using the concept we used in our former lesson. So you take the negative this thing of square root of 2 and 5. So sine 50 becomes 0.7660. So I want you to run a check on this. So sine 50 is 0.7660. Cosine, you can just assume any number that ranges from within 0 and 90. Okay, let's use 60 or 70. Okay, let's use cos 70. Now, applying the same rule as discussed in our last lesson, you discover that cos 70 will be giving you cos 70 1/4, which is about 0.3420. That's it. We can also go ahead into using any arbitrary number. Okay, let's just use let's do that of tan. Okay, let's say 32 degrees. We'll be giving you values like 0.32 is 0.6249. Okay, you can see from what we have here that the values of sine, cosine, and tangent of any number ranging from 0 to 90 is always positive. We had 0 point this, which is a positive value. 0 point, we do not have anything like minus 0 point any of these values. That's all about the first quadrant. So in the first quadrant, all the values of sine, cosine, and tangent always assumes a positive value. Now I would like us to take a walk to the second quadrant. Now remember, when you're talking about the second quadrant, before you deal with it, the first thing you have to do is to sketch your circle. Never mind. Wow, my circle looks like a dough, but it's still nice. Now let's go into detailed analysis of what we have in front of us. Remember, this is the second quadrant. We just did justice to the first quadrant. Let's project an angle to this point, bring it down, okay, and we call this point theta. Remember what we specified. This is a minus x, and this point is called this is a positive y because it's synonymous with this. Then this is a minus y, and this, let's still use the word p for the resultant between this. Now with this, always remember to put down your SOHCAHTOA. Now you know why? Because it actually serves as a guideline into what we're about evaluating. So let's go into the analysis and apply it. Remember, so the S is for sine, C is for cosine, and T is for tan. Now in the second quadrant, if you want to write the value, and second quadrant consists of, I said the other time that we have 0 to 90 degree in the first quadrant. So the second quadrant ranges from 91 or above 90. So you can call it 90 point anything, from 91 to 200 to 180 degrees. So to 180 degrees. So with this, we'll be dealing with angles that falls within this range. So let's deal with sine theta. Sine theta is equals opposite. The opposite of this angle is y, all over hypotenuse is what? P. This is for sine theta. Let's put a comma here. We have that of cos theta to being cos says adjacent over hypotenuse. So where is the adjacent? Adjacent is minus x. Minus x over the hypotenuse here is P. And tan theta goes with the symbol. That's opposite over adjacent. So we have opposite. The opposite part of it is y. All over the adjacent is minus x, which is equivalent to minus y all over x. Now you will bear with me that in the second quadrant, it's only the sign of numbers that falls within this range that assumes a positive value. That is to say, if we have numbers ranging from 91 to 180, the sign of such number will always be positive, while the cosine or the tangent of such numbers will be negative. If I should tell you to give me the value of sine 120, it will be a positive value. But but cos 120 and tan 120 would definitely be a negative value. I want us to take a proof into what we've just done. But when it comes to range of angles in this quadrant, you know, the angle ranges from here to this point. So here to here becomes 180 minus theta. Now this symbol is being applied because from the origin to this point is 180 degrees, just like what we stated in our last section. Here is 90 and here is also 90. So if here is 90, here is 90 and here is theta, so the whole of this point is 180 minus theta, and it's called angle of equivalence. So at this point, if you're being given a value to sort for, let me say a value that is as high as cos times sine. Okay, let's go with the value like cos 95. Cos 95, the first thing you're supposed to have at the back of your mind is that cos in the second quadrant should be negative. So any number you're having should assume a negative value. If not, you're far away from the correct answer. So when we have cos 95, and remember I said something about equivalence. So if this is 95, so the equivalence of it in this quadrant is being written as 180 minus 95. So cos 95 is the same thing as cos 180 minus 95, but with a negative value being attached to it, because that's the law. In the second quadrant, cosine must be negative. And if you go into analyzing the value of 180 minus 95, okay, let's do that. 180 minus 95, you pick one from here. 10 minus this is 5, this and 8. Okay, that's 85. So we now have minus cos 85. So if you have a way of going through it, if you press sine and cos 95 on your calculator, you discover that it will give you the same value as being as minus cos 85, which is the same thing as 0.0872. This is minus 0.0872. The minus value being attached to it is as a result of being a member of the second quadrant. Okay, let's do that of tan 110, or can we? Okay, let's do one. Okay, let's leave it at 110. Tan 110, just like what I said, tan assumes also has a negative value in this quadrant, so is equivalent to minus, you write tan 180 minus 110, which is the same thing as minus 180 minus 110 is just 70, which is the same thing as minus tan 70. And what is the value of tan 70? Tan 70 is 2.4 Okay, 2.747. 2.747 with a negative sign, because since it's a member of the second quadrant. So tan 110 is equivalent to minus tan 70 degrees. So, but if you have a value in this quadrant, let me say sine 100 and okay, let's do 135. Sine 135 degrees is the same thing as sine 180 minus 135. So, which is equivalent to sine 45 degrees. Remembering that sine in the second quadrant is always positive. So the answer becomes 0.7071. So with this, you see that when you come into the second quadrant, it is only the sign of angles that falls within this range that is usually given the positive value. Others assumes a negative value, like if you're talking about the cosine of angles, the tan of angles, they have negative values in this quadrant. But in the first quadrant, if you want to make a review of what we did in the beginning part of this lesson, you discover that in the first quadrant, all the trigonometric functions has a positive value when it comes to cosine, tangents, and the sine of angles. I think with this, I would like us to always use this place to refresh your memory on what we've just discussed, and in no distance time, tests will be popping up here for you to make justice to it. Do well to always use this lesson notes on the platform for a better information on the topic we've just discussed, and we'll always be waiting for a question on the comment section. So thank you. See you in our next section.